Hola, ¿qué tal, comunidad de Spaceport? ¿Cómo están? Hoy no es una transmisión más. Hoy estamos mirando algo que la humanidad no había visto en más de 50 años. Y la misión Artemis 2, que como todos saben se lanzó el 1 de abril desde el Centro Espacial Kennedy, con 4 astronautas que están a bordo y ya están en pleno vuelo lunar en una trayectoria que rodea la Luna y los devolverá a la Tierra. Recordemos una vez más sus nombres: Reed Wiseman, comandante; Victor Glover, piloto; Christina Koch y el canadiense Jeremy Hansen, ellos dos especialistas de misión. Victor Glover se convierte en la primera persona de color en volar alrededor de la Luna, un hito también que se cumple en esta misión. Christina Koch, la primera mujer, y Jeremy Hansen, el primer no estadounidense en hacerlo. Entonces estamos el día de hoy experimentando varios hitos, estamos viendo cómo se hace la historia. Esto no es solo un viaje, es un regreso de la humanidad a un lugar que siempre ha estado ahí, pero que ahora estamos empezando a entender con nuevos ojos. Hoy a las 2:45 p.m. hora del este comenzó el periodo oficial de observación lunar. Son 7 horas de observación científica desde el espacio. Durante ese tiempo, los 4 astronautas están enfocados en algo que ningún instrumento puede hacer solo: mirar. La científica Kelsey Young lo explica de esta forma: sabemos de qué está hecha la Luna, sabemos de su topografía, pero no sabemos qué va a ver la tripulación bajo estas condiciones específicas de iluminación. Y eso precisamente es lo emocionante, porque cuando un astronauta mira la Luna, ve historias de geología que ocurrieron hace millones de años. Y como el espacio en las ventanas de Orion, el tiempo será limitado. Solo durante 55 a 85 minutos podrán tener esta ventana de observación, mientras todos descansan y luego rotan. Pero, ¿qué están viendo exactamente? La NASA le asignó a la tripulación una lista final de 30 objetivos. Estos objetivos de observación lunar son 30 lugares que tienen historia en las rocas. La primera es la cuenca orientale, que es un cráter de casi 600 millas de diámetro que abarca la transición entre la cara cercana y el lado oscuro de la Luna. Se formó hace 3.800 millones de años, cuando un objeto de gran tamaño impactó la superficie, y conserva evidencia dramática de esa colisión en sus anillos topográficos. Un recordatorio de que la Luna fue literalmente moldeada por estos impactos colosales. También estarán observando el cráter Ohm con sus rayos brillantes, como si la Luna aún estuviera contando la historia de su propio nacimiento. El cráter Pierazzo, donde la roca se derritió, fluyó y volvió a solidificarse, es prácticamente un laboratorio natural de geología extrema. Y el cráter Glushko, una ventana a procesos más recientes en la superficie lunar. Pero lo más poderoso no es el lugar en sí, es la perspectiva. Primero, ¿se acuerdan? Van los astronautas equipados con ojos para mirar cosas que los instrumentos no pueden hacer, y eso nos da una perspectiva. La nave Orion se acerca a la Luna a una distancia mínima aproximada de 6.500 kilómetros de la superficie. Eso significa que ellos van a estar viendo detalles microscópicos que no se pueden ver igual desde acá. Y estarán viendo estos detalles, son el contexto geológico de la Luna, y también nos da a nosotros una idea de la escala planetaria de lo que estamos observando. En ciencia, el contexto lo cambia todo. El lado oculto de la Luna solo estará parcialmente iluminado durante el sobrevuelo. Por esas condiciones se van a crear como sombras que se van a extender por la superficie y nos van a permitir también ver otras cosas que no podemos ver a simple vista. Podemos ver con más profundidad las crestas de los cráteres, las pendientes, los bordes, que bajo iluminación total pues es difícil detectar. Es como la diferencia entre fotografiar una montaña al mediodía, cuando todo lo ves plano, a fotografiarla al atardecer cuando el sol cae y puedes ver las sombras sobre la montaña. Entonces, las sombras nos ayudan también a revelar detalles que no podemos ver a simple vista con los instrumentos actuales. También hay otras cosas que están buscando activamente, como destellos producidos por impactos de meteoritos en la superficie lunar, meteoroides, datos reales sobre los peligros que pueden enfrentar en las futuras misiones. O sea, ahorita se trata de observar y detectar todo lo que podría dañar la misión a futuro. Pues porque la luna no es un lugar donde no pasan cosas, sí están pasando cosas, está viendo, todo el tiempo está siendo impactada por meteoroides, todo el tiempo está recibiendo radiación de diferentes formas y esto puede impactar futuras misiones. Entonces es un mundo, la luna es un mundo activo, aunque nosotros pensamos que solo la vemos así, siempre está en constante interacción con el espacio y obviamente con la Tierra. En algún punto de este sobrevuelo ocurrirá algo que nos va a poner los pelos de punta, porque cuando la cápsula Orión pase detrás de la Luna, la misión estará en un apagón de comunicaciones de 40 minutos. O sea, no vamos a saber lo que pasa. Sí sabemos lo que pasa por instrumentos y hay otros sistemas de comunicación, pero la comunicación real que estamos oyendo ahorita no va a existir. La superficie lunar bloqueará completamente las señales de radio. Entonces, 4 humanos estarán completamente solos del otro lado de la luna sin contacto con la Tierra. Eso no ocurría desde las misiones Apolo, entonces también ese es otro hito. Y cuando vuelvan a comunicarse al final de este sobrevuelo, la tripulación observará un eclipse solar, por si fuera poco. Esto es un detalle fantástico, ¿no? Ellos podrán observar un eclipse solar desde el espacio. El sol desaparecerá detrás de la luna durante casi una hora desde la perspectiva de Orión, o sea, donde ellos están. Durante ese tiempo verán la luna casi completamente oscura y aprovecharán, obviamente, para analizar la corona solar, la atmósfera exterior del Sol que va a estar asomándose por los bordes de la luna. Y como si todo esto fuera poco, hoy, durante este sobrevuelo, la tripulación superará el récord de distancia máxima de la Tierra que jamás hemos alcanzado como humanos. Apolo 13 ya había llegado a 248,000 y pico, casi 250,000 millas en 1970. La Artemis 2 llegó a 252,000 y piquito. Entonces, estamos hablando de una diferencia importante, de unas 4,000 millas, más lejos de la Tierra de lo que ningún ser haya estado antes. Lo que estamos viendo hoy no solo es tecnología, comunidad, es una decisión también. La decisión de la humanidad de volver a mirar hacia arriba, de volver a explorar con ojos humanos lo que los satélites solo pueden ver desde lejos, las observaciones que esta tripulación obtendrá van a construir van a ayudarnos a construir el orbitador lunar, el Lunar Reconnaissance Orbiter, que, que se va a lanzar en las siguientes misiones. Entonces, también todo lo que hoy vamos a aprender ayudará a planificar los sitios de aterrizaje de las futuras misiones. Artemis 2 no es solo una misión de prueba, es el principio de un capítulo. Estamos haciendo historia y es esta historia que llevará a los humanos de regreso a la superficie lunar y eventualmente más allá. Y nosotros aquí desde Spaceport queremos decirles que llevamos años diciéndole a América Latina que el espacio es un lugar que no es solo para los demás, que no es un lujo de otros, que es un territorio que no es ya una vez más, no sigue siendo un territorio exclusivo de las grandes potencias. Ahora nuestra región sabemos, reconocemos y entendemos que tiene talento, tiene historia, tiene visión y también tenemos todo el derecho de estar en la conversación. Lo que está ocurriendo hoy con Artemis no es un evento lejano. Eso es algo que nosotros queremos reforzar mucho aquí desde Space por MX. Sí tiene que ver con nosotros. Es una señal de que la nueva era espacial se ha abierto. ¿Se acuerdan? Nosotros llevamos fácil 6 años hablando de hábitats en el espacio, de la construcción y la conceptualización de hábitats, el diseño. Hoy día ya no es un cuento que parece de ciencia ficción y tenemos más de 1,400 estudiantes que ya han sido impactados con programas donde ellos ya saben de lo que estamos hablando. Tenemos ya una fuerza laboral dirigida hacia las industrias que vamos a ver desarrollarse en los próximos años con una velocidad impresionante. Por lo tanto, debemos empezar a creérnosla que podemos entrar por la puerta de enfrente. Cada niña y niño que hoy estén viendo este sobrevuelo en México, ya sea en Colombia, en Argentina, en Chile, en cualquier ciudad de nuestro hermoso país, están viendo la historia de la exploración y la permanencia de humanos en el espacio, pero también están viendo un futuro posible. Ya no lo están viendo como solo quiero ser astronauta, ahora están viendo toda la cantidad de profesiones que están disponibles para ellos y también las posibilidades tan impresionantes que hoy día hay para participar desde ámbitos de sociología, de ciencias sociales, de ciencias administrativas, diplomacia, medicina, psicología, desde tantas trincheras donde podríamos hoy día encontrar un futuro posible para nosotros. Y cada ingeniero, cada científico, cada emprendedor en nuestra región que hoy trabajan con tecnología espacial también están construyendo ya un puente que nos va a llevar ahí. Entonces ya estamos entrando en un punto donde debemos reconocer eso como una realidad para nosotros. Fíjense, en los talleres de niños hemos llevado al espacio a través de nuestras actividades a más de 1,580 niños con todos los talleres que hemos desarrollado. Están aprendiendo sobre ciencias planetarias, están aprendiendo sobre cohetes hidropropulsados, además se divierten, juegan, aprenden de una manera que queda grabada en su experiencia vivencial. Hemos dirigido fácil, hoy día tenemos más de 50 jóvenes que ya tienen sus carreras dirigidas a ciencia y tecnología con aplicaciones espaciales o para empresas que están haciendo, son contratistas o son parte del ecosistema de la industria espacial actual. Entonces, no hacemos todo esto porque seamos una gran corporación o porque sea muy fácil para nosotros, lo somos en el sentido del trabajo que hacemos, pero somos todavía una iniciativa que cree profundamente que el espacio es un derecho humano y que la próxima historia espacial puede tener acento mexicano o latinoamericano. Y pues hoy somos testigos de algo que solo ocurre una vez en la historia. Un momento donde la humanidad está volviendo a rodear la luna, está orbitando un gran 8, vuelve a observar, vuelve a sentir que pertenecemos a este universo. Y cuando esta misión concluya, los astronautas regresarán a la Tierra con un amerizaje en el Pacífico, trayendo consigo imágenes, datos, experiencias que darán forma a todo lo que viene después. Entonces, este es el comienzo de una era dorada para la exploración espacial y sobre todo una era donde todos podemos formar parte de esto que es ahora la industria del nuevo espacio. Y pues hoy el universo nos está llamando y 4 seres humanos que están allá afuera representan a miles y miles de personas que hicieron posible esta misión. Entonces, no se lo pierdan, por favor, acuérdense. Va a haber datos cruciales, va a haber cosas importantes que van a estar pasando. Vamos a estar observando regiones específicas de la Luna y obteniendo información con nuestros ojos y con instrumentos. Va a haber 40 minutos en un momento que las telecomunicaciones no van a funcionar, que van a ser bloqueadas por la luna y también vamos a presenciar un eclipse solar desde la perspectiva de Orión, se va desde allá arriba y además vamos a presenciar en las siguientes horas, bueno, los siguientes días al final de la misión, uno de los retos más grandes que es la reentrada, ver que sea posible que sobrevivamos a ese calor intenso. Entonces, bueno, vamos a estar por aquí siguiendo los datos más importantes, tratándoles de traer una perspectiva más explicada de lo que sucede. Y quédense, porque sigue la transmisión y aquí seguimos todavía. Nos vemos en unas horitas más. Chao.
traveled from our home planet. At that time, over 55 years ago, Lovell, Swigert, and Hayes flew 248,655 statute miles away from Earth. Today, for all humanity, you're pushing beyond that frontier. Integrity, over to you.
From the cabin of Integrity here, as we surpass the furthest distance humans have ever traveled from planet Earth, we do so in honoring the extraordinary efforts and feats of our predecessors in human space exploration. We will continue our journey even further into space before Mother Earth succeeds in pulling us back to everything that we hold dear. But we, most importantly, choose this moment to challenge this generation and the next to make sure this record is not long-lived.
Thank you, Integrity, and congratulations to you and the rest of the Artemis II team.
Thank you, Houston. We have a couple more things we'd like to take this moment for. Our science team helped us out with a couple of relatively fresh craters on the moon that have not been previously named, and our crew would like to propose a couple of potential names for those items or those areas. And we spent a bit of time this morning looking out the window, and we're able to see them now both with our naked eye and through the long lens, and so we feel this is a good time to send this down, and a special shout out to Kelsey for helping us with this. The first one we'd like to suggest is a named crater in honor of our great spacecraft Integrity. And so if you were to look at Orion on the far side and then draw a line straight up to Ohm on the far side, relatively in the middle is an unnamed crater, and we would like to suggest it be called Integrity in the future. And the second one, and especially meaningful for this crew, is a number of years ago we started this journey in our close-knit astronaut family, and we lost a loved one. And there's a feature in a really neat place on the moon, and it is on the near side, far side boundary. In fact, it's just on the near side of that boundary, and so at certain times of the moon's transit around Earth, we will be able to see this from Earth. And so we lost a loved one. Her name was Carol, the spouse of Reed, the mother of Katie and Ellie. And if you want to find this one, you look at Glushko, and it's just to the northwest of that, at the same latitude as Ohm, and it's a bright spot on the moon. And we would like to call it Carol, and you spell that C-A-R-R-O-L-L.
Integrity and Carol Crater, loud and clear. Thank you.
As the Artemis II crew passed the record set by Apollo 13 for the farthest humans to ever fly from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time, Canadian Space Agency astronaut Jeremy Hansen shared.
We're getting ourselves all put back together now, and we are going to dim the cabin lights and prepare for our science objectives ahead. Thank you.
Sounds good. We're doing the same down here, and you're maneuvering to your observation attitude.
As we pass that Apollo 13 record of the furthest humans to ever fly from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time, the Artemis II crew shared some poignant words, specifically Canadian Space Agency astronaut Jeremy Hansen. The crew also called down 2 craters not yet named that they would like to name. One, Integrity, in honor of their spacecraft, which they have named. That's near the Ohm crater. Another near Glushko, which is a bright spot, named Carol, in memory of Reed Wiseman's wife. There was a moment of silence here in Mission Control Houston. And now the team and the Artemis II crew are ready to begin their lunar flyby. We are 4 days, 19 hours, 31 minutes mission elapsed time of the flight of Artemis II, our 4 astronauts aboard Orion. Today is our lunar flyby day. The spacecraft is currently about 12,000 miles away from the moon, and you can keep up with the distance from Orion to the moon and Earth by visiting nasa.gov/trackartemis, or you can just stay with us here because we're going to be telling you throughout the day. They are currently 248,834 miles away from planet Earth. Coming up next on the crew's timeline today will be their cabin configuration portion. You heard some calls down to Science Officer Dr. Kelsey Young earlier about how they have configured the cabin so far. This is just a little bit more of timelined activity for them if they need to further do so. On flight day 3, the crew had time on their schedule allotted for configuring the spacecraft cabin for how they intended to arrange it today. Of course, they had to take down that configuration for another test yesterday of their Orion crew survival system suits. But configuring it on flight day 3 allows them the opportunity to get a chance to see what works for them now that they are in the microgravity environment. Again, the crew is about to begin their cabin configuration portion of their timeline, though they have been working that already, as well as potentially during their post-sleep period this morning. The official lunar flyby observations are slated to begin in just about 40 minutes. That's when we'll have the crew at the windows photographing the moon, as well as making calls down about what they are seeing. Again, we are live here in Artemis Mission Control for the duration of the flyby. Currently, the Orbit 1 flight control team is on console. This room is staffed 24/7 from the time before the astronauts step foot on the rocket until the time they splash down and are safely recovered in the Pacific Ocean on flight day 10. Again, this is Artemis Mission Control here in Houston. We are now 11,777 miles away from the moon. We did pass the Apollo 13 record of farthest humans away from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time. That distance, 248,655 statute miles from the Earth, continuing to be exceeded by the crew. They will reach their farthest distance from the Earth around 6:07 p.m. Central Time. At that time, they will be in an LOS, or a loss of signal, with us on Earth, as they'll be flying behind the moon. As the crew get configuration preparations, we're joined by Dr. Artemis Lunar Science Lead. Thanks for joining us here today.
Yeah, it's quite a day.
Yeah, we are very excited. I can only imagine how you're doing over there. So tell me a little bit about yourself and what your role is for Artemis 2.
Sure. So I'm the Artemis Lunar Science Lead, so over the entire campaign, and my job is basically to make sure that as we have this big adventure back to the moon, we actually learn new things about the moon.
Fascinating. So why is the moon such an important destination today?
Yeah, so the moon is a pretty amazing place. It is a great place to learn about basic fundamental processes that happen on like all the planets, like cratering and volcanology. And also, it is, part of our Earth-Moon system. And, the Earth recycles its rocks pretty well, right, through plate tectonics and weathering and whatever. Most of the rocks on the Earth are geologically young. But on the moon, we have the entire record that goes back 4.5 billion years since we formed. And so if we really want to learn about what was happening in that period, like, the moon is really the only place we can go.
We're also thinking about going back to the moon, and we want to go to the lunar South Pole. So what makes that such an interesting destination?
Yeah, the South Pole is cool, right? It's far away from the places we went during Apollo. It's different kinds of rocks there, some of the oldest rocks on the moon. It's also a place where we think there might be resources like water. There are craters that really never can see the sun because of the low sun angles there, and they get very cold. And we think that water and other things can build up in those craters, and so we're very interested to see what that might do for us.
I'm very interested as well. So for some of our viewers who might be new to this, what does lunar science look like during an Artemis mission?
Yeah, it's pretty exciting for us as we have sort of built this from scratch to try to understand how we can best use the crew to support our science. And so, we've developed a system. We've got a team in place. We've got a back room here in this building called the SIR, the Science Evaluation Room. And there's in fact a back room to that back room over in another building here at Johnson Space Center where we've got our teams of scientists working really hard. They're actually speaking to this room through our science officer. This is now the first time we've ever had a science officer in flight control room. So we're pretty excited about that. So we have a really voice out and up to the crew.
I know, it's been so exciting to hear Dr. Kelsey Young speaking directly with the crew today, now so close to the moon. And we have a live view here of the science operation or the science evaluation room. So this is where the majority of your team is today. Is that right?
Yeah, that's right. This is a big chunk of our scientists. You can see them in there now working hard, trying to get ready for the day. And then again, there's a second room where we have a lot of our data folks, where the data will first come down and they'll sort of sift through the data and get it ready for this team to take.
What's the mood like right now in the SIR?
It is, I would say, giddy. I think we've worked very hard for this. They have done simulation after simulation. They have worked really hard over the last couple of years to get ready for this moment, and I think everybody's just really excited to see. Even already we've had some descriptions from the crew coming down, and it's so great to see their joy and our joy, our love for the moon come through.
Yes, we are in for a real treat today if it's been anything like their observations the past couple of days. So how are the lunar science teams using this test flight to prepare for future missions to the moon?
Yeah, absolutely. This is the way that we are building our foundation for the future, from everything from, how do you train a crew to be a geologist, right? And so, working through that, getting them classroom training, field training, building the science team, building these physical rooms that we are in, designing the software that the teams are using, and then, figuring out what happens to that data. They're going to take this data and it's going to come down, and how do we get it out to not only our team, but out to the world and the rest of the science community?
Yeah, that's a great point, because when you hear these crew members talk, you would never know that they're not geologists. Your team has trained them so well.
They have been very good students.
Who can blame them? It's a pretty great topic. One more question for you. How does the science that we're doing on Artemis help support long-term exploration and including our sustained presence on the moon?
Yeah, you know what? We have a saying in the Science Mission Directorate that science enables exploration and exploration enables science, right? So you need the scientists, because we are the ones who are the experts in, landing site and doing analysis of landing site and making sure we can find a good place to land, to understanding the properties of the soil so we can, design our systems to manage that, understanding the radiation environment, keeping our astronauts safe, all of these things, right? But, in return, you provide us with opportunities where now we're going to be able to collect this data and collect samples and deploy our instruments and all of that. So it's a symbiotic relationship.
That makes perfect sense. Well, Dr. Sarah Noble, Artemis Lunar Science Lead, thank you so much for joining us here today. Best of luck to you and your team, and I hope that you get to enjoy today too.
Thank you so much.
We are now getting closer and closer to our lunar neighbor. This live view coming from the Orion spacecraft and a camera mounted on one of its solar array wings.
Houston, integrity for camera serial numbers.
Ready to copy.
Hey Jenny, these are card numbers for the various positions. For the long lens on the D5, we will have individual cards. Victor's 1008, Jeremy 1019, Reed 1012, myself 1015. For the Z9, we will have one card that is dedicated for today, serial number 1007. For the cabin camera D5, we will have one dedicated card for today, serial number 1022.
All right, Christina, we copy all. Thank you.
We just realized that we have Earth out window 1 and Moon out window 2, and Earth out window 4 and Moon out window 3, and it gives you the best idea of scale we have had yet. The Moon is about 3 to 4 times the size of the Earth, and it is almost full, and the Earth is just a small crescent out there. It's magnificent. I got a picture of it with the wide lens. Such a majestic view out here.
Amaze, amaze, amaze. Thank you, Reed.
Those are some of the communications we're excited most about today. Commander Reed Wiseman calling down their view right now. Obviously a little bit different than what we can see from the solar array camera. They are looking through the windows of the Orion spacecraft, able to see at the same time Earth and the Moon. You also heard NASA astronaut Christina Cook calling down some of the cameras that they will be using today. The crew is in that cabin configuration portion, and we expect the lunar flyby observation period to start in just about 20 minutes. Checking in on Orion's distance and speed, they are currently traveling 1,071 miles per hour, 249,159 miles away from Earth, 11,293 miles away from the moon, and continuing to grow closer. At closest approach to the moon today, the spacecraft will be just about 4,070 miles away from the lunar surface. This will be during our loss of signal with the crew as they travel behind the moon, and we will await their return to get the official number for you for how close they come to our lunar neighbor. Inside the cabin today, the lunar targeting package is the primary tool guiding the crew observations and consists of two key components. The lunar geography review helped the astronauts study major lunar features in advance and help learn how to orient themselves during the flyby. Because, of course, the moon is not actually labeled like it appears here when we look at this map. The lunar targeting plan provides a detailed timeline of observation targets, background science context, and specific instructions for the pictures the crew should take, as well as the verbal descriptions that will be helpful to the science team reviewing them later. This is a screenshot from their lunar targeting package and a screenshot specifically of that lunar.
For attitude.
Go ahead.
Hey, Jenny. Understanding we are in final attitude now for the lunar flyby, would it be possible to pitch the vehicle down 5 degrees? That would allow us to get the D5 long lens flush and have the least amount of window distortion.
We're checking.
That call from Christina Cook, NASA astronaut and mission specialist on Artemis II.
Copy.
The Orion spacecraft is positioned in a specific attitude to allow the crew to best see the moon outside of their windows today for this imaging opportunity. That call was a request for a potential attitude shift just slightly, another 5 degrees, to give them a better view and to give them a better opportunity to use their long lens camera. They'll also be using that lunar targeting package we were discussing. I am following along with that real time, so I'll be able to share with you exactly what targets the crew is looking at and when. They also trained with a lunar science passport. It's a little reference guide used on Earth to reinforce recognition of key lunar features. It is not on the flight, but it was a significant study tool for the crew to get them ready for launch. The apparent size of the moon will change throughout the flyby, and it'll appear roughly like a basketball held at arm's length at the crew's closest approach. That reinforces the need for careful planning and practiced observation techniques.
Houston, integrity for timeline.
Go ahead.
Hey Jenny, just to make absolutely sure that we start observations when expected, we are showing in Optimus that observation time starts in about 15 minutes, and in LTP that our first target, discussion 1, starts in about 29 minutes. Can you confirm you'd like us to start discussion 1 in 29 minutes at 1900 GMT?
Christina, we are tracking that discussion 1 should start at 18:45. That's 15 minutes from now.
Okay, copy all. It may be a granularity issue with LTP, but understand that we start that observation in 15 minutes, and I bet when we get there, the green line in LTP will match the start of the white band for discussion 1. I think it's just a matter of the labeling and the granularity. Thanks for confirming.
Copy, and we'll look into that a little bit more on our side as well. Christina, can you verify for us that your green line is moving on the timeline page of your LTP?
Affirm. Jenny, I do think we're good. Looking closer, I see the labels are just not aligned with start or end times of the white visible bands. It fully makes sense now, so I think we are all set. We'll look forward to starting some observations in about 13 minutes.
Copy. Thanks, Christina.
As you heard discussed, we are expecting the crew's observation time period to start in about 10 minutes. First, they'll be conducting a warm-up, warming up to their science observations of the moon. They'll be discussing with each other, helping each other orient using the major landmarks that they've studied, asking what is familiar.
If we roll left, port 5 degrees, that would get the moon closer to the of window 2.
Copy, Victor. We'd like to know if it's pitch and roll or one or the other.
Jenny, we actually thought you already put the pitch in. Had the pitch been put in already?
No, we need a little while longer to talk about it.
So Jenny, I guess what's happening is just as our orbit's changing, where it is in the window is changing, so maybe these fancy little adjustments aren't worth it. It's going to continue to move in the window. Or is the spacecraft going to keep the moon at the same point of the window if we adjust the attitude? I assume the previous.
Right now, we are pointing the center of the window to the center of the moon with 2 degrees of advance.
The conversation here and mission control here at Johnson Space Center in Houston, Texas. They are in the center of your at the Capcom or Capsule Communicator Console. She was all lead Capcom for Expedition 63 aboard the International Space Station. The crew is requesting some attitude changes to the spacecraft to allow them to better image the moon, our priority for today. Of course, those have to be discussed before the spacecraft. Team is taking some time. So, you also heard Gibbons reference that we are in 2 dead bands. Dead bands are essentially keeping us in the lane in which we're traveling. If you're familiar with lane assist in your car, very similar in this case. We are now 10,807 miles, traveling 1,006 miles per hour and 249,390 miles away from Earth. Again, we recently surpassed the Apollo 13 distance record of farthest humans have ever traveled. And upon calling down some words during that milestone, Canadian Space Agency astronaut Jeremy Hansen noting that he hopes that this record that they are setting today is soon broken by future explorers. This is Artemis Mission Control. We are standing by for the beginning of lunar flyby. Expecting that to start in just a few minutes when the crew will begin a warm-up discussion preparing for the day. They will be capturing images along while discussing what they find familiar about the moon and what looks unexpected to them. Again, just minutes away from the official start of lunar flyby, or when it is timelined for the crew. We are currently 10,726 miles away from the moon. This view on the left side of your screen coming from the camera on one of Orion's solar arrays. Other conversation points while the crew are getting ready for their flyby today. They'll be looking to orient themselves using major landmarks and annotating their observations along with their discussion. They'll have 10 minutes for that warm-up discussion.
Houston integrity. We have two folks at the window deep in discussion talking about all of the awesome features that they're seeing. We just had a huge moment realizing that Hertzsprung is about the same size as our incredible Oriental. We're really excited about this target that's kind of new to us. We're orienting on things like how we talk about albedo, finding some of the prevalent things that we're used to from all of our training, and just overall taking in this view. We also are noticing that the moon is still getting noticeably bigger as we go, even when you're watching it continuously. It's great to see these two guys get warmed up.
We love the report, Christina. Thanks. And you nailed it on why we added Hertzsprung. As you'll see in the prompts, we're looking for comparisons to the comparatively much older Hertzsprung compared to the younger Oriental. Great words.
This is Artemis Mission Control. That was the voice of Dr. Kelsey Young speaking with the astronauts aboard Orion as they begin their observation period and lunar flyby. NASA astronaut Christina Cook reporting their view of Hertzsprung Basin. The team here is looking for centered images of the basin at a full zoom, and they're hoping that the astronauts can image and describe the inner and outer rings. This is considered a degraded basin with a floor, rings, and ejecta compared to a younger Oriental basin. We spoke earlier with Julian Gross, the Artemis curation lead, about some of the terms we will hear the crew use today. One of those just called out, that's albedo, looking at surface brightness, or the amount of light a surface reflects. A few more terms that we hope to hear today during the crew's sit reps or situation reports include embaying. This refers to one feature that surrounds another. That usually is a higher relief feature.
Houston Integrity, one report from the crew at the windows. We can actually see the moon and Earth at the same time right now. It's interesting because the Earth looks way brighter, so the Earth itself seems to have a much higher albedo than the moon. We think this is independent of our eyes focusing, because of course the Earth is much the moon in our view, so you could think that your eyes focus on a darker sky, and that it means that it only has apparent brightness more than the moon, but since we're seeing both in the same view, we do think that this can be inferred as the Earth as a whole has a higher albedo.
Great observation, Christina, and reminder that as you're starting to look for those subtle color and albedo variations on the moon, the relatively bright albedo Earth might make those a little bit difficult, but as your eyes continue to adjust, we expect you to start to see more nuance on the moon. Thanks.
Great call. Thanks for the reminder.
We're all going to be experts in lunar terminology by the end of the day. Another one we expect to hear is mare. These are dark regions paved or filled by volcanic deposits. You also can hear them called seas, oceans, lakes, or marshes, or other bodies of water. Again, we are live in Artemis Mission Control, but on the right side of your screen, that is the Science Evaluation Room, team members who have been preparing for this day for years. The crew has significantly darkened the cabin of Orion. This allows them better views outside the windows and fewer reflections from inside. They reported being able to see the moon and the Earth out the same window at this time. We are really hopeful to get those photos. Right now, this view on the left side of your screen coming from a camera mounted on one of the array wings and outside these craft. Equipped with 80 to 400 millimeter zoom lenses. The team continues their warm-up discussion. I should say the crew members aboard Orion continue their warm-up discussion. However, they are about to be prompted to move on to discussion number 2, which is near side and far side. Some of the things that they are looking to capture, the ground has prompted them to photograph anything that stands out to them and to compare the near side versus the far side mare in color, albedo, topography, and texture. They also want the crew to compare the appearance of rayed craters in the near side mare versus in the far side highlands. Of course, a reminder that some of the items that the crew, or some of the landmarks the crew are seeing today, is the first time that humans have ever laid eyes on those portions of the moon. In the targeting package, there are a few reminders of the crew. For the crew, there are time-sensitive observation reminders and science sit rep reminders.
Integrity. We have a sit rep. The targets that are being discussed right now, it's the far side, near side comparison, and hearing some great discussion of browns and greens in the Aristarchus Plateau and how those disappear as you go toward the North Pole, and then over to the far side, you lose the color. You've got Jeremy in window 2, Reed in window 1, having a great discussion. Christina's under window, I'm sorry, Reed is in window 3. Christina's under window 1, documenting the discussion. And we've got the lights completely off in the cabin. There are some LEDs that we cannot put out that do provide some light scatter. But we have all of the internal lights off. And are letting our eyes adjust as best we can. The window 4 view, you only get about a third of the moon. Tycho is going to go over the horizon soon, and you can see Aristarchus, and then you start to lose the view as you go to the west in Oceanus and Procellarum. So far, the team is on the plan, and the long lens is being put to good use, and recordings are being made, and internal documentation of the configuration and the observations is ongoing. Science, do you have any questions for us at this time?
Integrity Science, Victor, very glad that you provided the first formal science sitrep, as these were indeed your idea. One follow-up question, any relationship between those browns and greens you described? Do you see them blending into one another, and do you see any topography associated with either color?
I don't want to bother the window team. I just heard that, overheard that, and so I'm sorry I don't have that detail yet. I will eavesdrop and see if I can pick that up. I will try to answer that at some point. I also heard a comparison of the albedo in Aristarchus, that crater, the very high albedo spot you can see on the near side. There is a feature called, I believe, Burgess Alpha that is equally or maybe higher albedo. I apologize for the gaps. I'm trying to listen and talk at the same time, but I will try to get some more information to correlate those colors from Aristarchus for you.
Understood, Victor, and good call to not bug the window team. Really like the brightness comparisons to Burgess A. Really helpful for the science team. Keep them coming. Thanks.
I also heard a discussion about the albedo of Grimaldi being a 10, and how many of us, when we were a little further away, saw that as the darkest albedo, and that the bigger Mare off to the west, sorry, to the east was still dark, but maybe a 7-8. We still think that, but you are seeing color variation, albedo variation inside of Grimaldi as well, and that even on the west side, there's still a very dark part of it. But it is still the darkest. It is just not as uniform as it looked when we were farther away. We're starting to differentiate the striations of albedo inside of Grimaldi.
Copy all, Victor, and you read our mind. Superlatives like darkest, biggest are really, really helpful for us, so keep those coming.
As we were just mentioning, the crew is slated to perform these science sit reps. They are prompted to do so by an icon in their lunar targeting plan. That one coming down from NASA astronaut and pilot of Artemis II, Victor Glover. As we discussed, the Capcom is usually the only person in the room speaking with the crew, the capsule communicator. However, today, the science officer, Dr. Kelsey Young, she is the Artemis Science Flight Operations Lead, is speaking with the crew during the flyby to ask any questions that the team may have. To her right is Trevor Graff. He is one of 3 science officers. Those would be Kelsey Young, Trevor Graff, and Angela Garcia, who will also join us later for an interview.
And Houston Integrity was able to, Science Integrity was able to get a view out of window 1, which is a beautiful view. I can see the entire moon that they're looking at. We left the T-shirt up there, so I was kind of peeking through the opening in the makeshift shroud there. And once I was able to get 2 eyes on it, what jumped out at me was Vavilov. It's just peeking out of the Terminator. It's clear of the Terminator now, but it just really jumps out because it's still got the low light, the low sun angle, And so where the, Vavilov has that impact over the top of another crater, where the two craters intersect on the eastern edge. So on the side closest to Oriental, where the two crater rings intersect, the shadow there is the highest peak in the interior of Vavilov, and so you can see that terrain is, there's some real variation in the terrain there, that there's a nice peak where those peaks intersect, where those rings intersect, and we'll get a picture of that.
Love the description, Victor, especially the comparison and relationships you just described about topography. And if it's easier for your observations, do feel free to remove the T-shirt shroud from window 1.
Yeah, absolutely, we will do. Thank you.
Those calls coming from NASA astronaut Victor Glover. As we discussed, the crew is working in pairs at the windows. Right now, taking photos are Commander Reed Wiseman and Mission Specialist Jeremy Hansen. Serving as their support team are pilot Victor Glover and Mission Specialist Christina Cook. You're hearing those calls from Victor Glover as he is on that support team, and he is tasked with providing the science sit reps, while the two crew photographing and making annotations of the moon are in Windows 2 and 3. Windows 1 and 4 are available for the support crew to fly up to, obviously look at the moon themselves, and provide these science situational reports. The view on your screen is part of the lunar targeting package, and it's something that the crew can reference as they are flying by. But this is an animation. You also heard Glover mention Oriental. Oriental is a major feature that the team is interested in today, and it's known as the Grand Canyon of the Moon. Until this mission, the Oriental Basin had never been seen in sunlight by human eyes. Oriental Basin and its surrounding ejecta could fit within a straight line distance from NASA's Johnson Space Center, where we are at today, to Kennedy Space Center. This a live view in Artemis Mission Control in Houston, Texas, where the teams are monitoring all systems, not just for today's flyby, but on the spacecraft themselves. Again, this is a test flight, our very first flight of humans on the Orion spacecraft. This team has been this team has been monitoring the entire time of the mission, as well as we have been live the entirety of the mission, and we will be continuing to do so all the way through splashdown and crew recovery from the Pacific. This is a visualization from ARROW, the Artemis Real-Time Orbit website that you can also access at any time by visiting nasa.gov/trackartemis, showing us that we are now under 10,000 miles from the moon, 9,948 to be specific, and continuing to count down. Again, our closest approach to the moon today should come about 6:02 p.m. Central, 7:02 p.m. Eastern. However, we will be out of contact with the crew at this time as they begin transiting behind the moon. At that time of closest approach, the distance from Orion to the lunar surface will be about 4,070 miles. Of course, these are estimates at this time, and we'll be sure to provide you with the official numbers once that closest approach has been reached. This shot live inside the Orion spacecraft, where our 4 crew members are continuing with their lunar flyby activities. They have just begun those activities really about 20 minutes ago, so we've got several hours of moon view opportunities. This is still a live view inside that capsule. However, you can see just how dark they have turned down the lights. Actually, they've turned them all the way off. There are a few LEDs that they cannot power off, but turning down these lights gives them better views outside of the spacecraft's windows while they photograph the moon. This also prevents any reflections from inside the spacecraft bouncing up on the windows and interfering with their photography. As we were previously discussing, the crew members are serving on teams, the first team being Commander Reed Wiseman and Mission Specialist Jeremy Hansen at the windows photographing what they see. We heard reports earlier that they could see both the moon and the Earth in the same view, and we are looking forward to seeing the moon and the Earth in the same view as well. That Earth set coming up in just a few hours. While Wiseman and Hansen are at the windows photographing, Glover and Cook are serving as support crew. They are able to assist with cameras. They are also providing those situation reports, letting us know how the team is working inside the spacecraft, what they're seeing, and how they're feeling about it. Those first blocks of teams will last about an hour, and the crew members are approaching the halfway point into their first observation block. A reminder, we have 5 of those blocks today. So they're approaching this halfway point, during which the crew at the window will switch roles. One will begin taking pictures, and the other will be making annotations on their PCD, that's portable computing device. Both of those crew members at the windows are recording audio of what they see. They are putting on headsets and recording audio into their portable computing devices. Obviously, we are not hearing this right now. This is going to be sent down to the science team, and they will be able to analyze that at a later time. What we are hearing, though, and will continue to hear, are those science sit reps a few times every block. Once this block is complete, about 40 minutes from now, we will have the teams switch. That means pilot Victor Glover and
Science integrity, looking out of window 1. I think I may have misreported earlier saying that it was Tycho going over the horizon. That was Copernicus I was referring to. Apologies. It was Copernicus is what is farthest bounding to the east, and that is now like on the horizon or just past it. And the Korolev is now a few degrees from going over the horizon. And then, next it'll be Aristarchus Plateau. And so on the west, we are getting a much better view of the Terminator. It looks like we have about 80% illumination of the moon. And Vavilov and 1 Vavilov diameter to the west is where the Terminator is right now. And so other features are starting to peek out there. The center of the illuminated part of the moon is to the lower part is Oriental, and just around Oriental, a lot of light structure is starting to show up. A lot of high albedo, similar to the feature, I cannot remember, Burgess Alpha and Aristarchus type high albedo in the ring. So when you look at the interior ring and the external ring, it's almost as if the edges are starting to dry up and turn white. If it was something that was wet and got dry, the edges would be the part to dry first. You just kind of outline all the topography in the interior of that wall is like it was dusted with chalk or started to dry, or maybe dusted with snow. If this was the Earth, I would say there was snow dumped on some of the ridges on the interior of the rings of Oriental. Also, an interesting part of the discussion that I heard between Reed and Jeremy is that from Glushko to Grimaldi, there are two dark features there that look like commas, but in the wrong direction. But there's also a lot of interestingness, just a lot of geometry and squiggles and dots and lines that are starting to stand out as more small features come into view. And there also is a lot of variation in albedo. In some of those, the two dark features, for example, have on the southern edge of the larger one, the one that's further to the south, is a very dark, the one albedo, like the southern and western part of Grimaldi. And the one to the north, closer to Glushko, is also that same dark albedo. And then around them, there are some very high albedo spots just to the north of the southern one, and just to the west of the smaller one to the north. Very high albedo, almost approaching the 10, a 9 or a 10, like Aristarchus. And lots of little bright spots just starting to pop up on in this view. To the north, as you look up at the North Pole, there is a very distinct crater with a lot of very defined central peak that is also 3 in albedo, and all of that area past it, going to the horizon, gets lighter and lighter, and is very, very high albedo. And I will go look and find the name of that feature if I can look that up. And then to the south, really getting some interesting geography and topography in the South Pole Aitken Basin. And the view of the South Pole is quite amazing. We've got some Terminator there, as well as the limb view, and there is a very distinct crater right at the South Pole. And I'm going to go look up, I don't believe that is Aiken, but I'm going to go look up the name of that one because it's also giving a lot of good topography due to the shadows that I'm seeing. But that's, I was trying to bound the view that I'm seeing for you, and I got distracted by all of these interesting albedo variations that are popping up in the interior. But that's the view that we see just a Vavilov diameter to the west beyond is where the Terminator is. Just beyond, I think Copernicus is the easternmost feature that we can see. A very nice ringed, very nice structure crater to the north with a great high albedo central uplift to the north, and the south is dotted by a very characteristic crater with a lot of terrain, shadow features, and I will go try to find some landmarks to put names with those. Any questions for the observation team?
Integrity Science, love the descriptions. You're definitely looking odd up there. Appreciate seeing the training being implemented. Especially interested in your descriptions of the dark patches. You compared the comma-looking features to the albedo you see in Grimaldi and noticed that you're starting to see those color differences popping out. Any observations you want to make, especially when you get on, the PCD in a little bit, would really help us tease out the differences in those dark mare deposits. Great description, Victor. Keep them coming.
Absolutely will do, and I know you've got descriptions on both of the window observers right now as well. Keep them coming.
great evidence of how well trained this crew is by the science team. NASA astronaut and pilot of the Artemis II mission, Victor Glover, calling down a situation report, noting several different features on the moon and such descriptions, even saying that it looks like snow on some of the peaks. Obviously, we do not expect that to be snow, but referencing that as some of the lighting on how it looks to the Artemis II crew from their current position. The team is slated to be switching their positions at the windows now. Both Reed Wiseman and Jeremy Hansen have been at windows 2 and 3, one taking photos, one making observations and annotations on their portable computing device. At this time, we also anticipate that they are looking at a crater duo. One of those is Glushko, and the other is Ohm. The team is looking to know the extent of Glushko's ray system and how its rays differ in the mare versus the highlands. They also want the team to ray systems of Glushko to Ohm. Ohm is considered a young crater. And if you've ever seen a photo of it's also known as the Eye of the Sahara, it's 40 kilometers in diameter, and that could fit within Ohm's interior. The team is specifically interested in descriptions of that ray visibility, including the color, albedo. Remember, albedo is the brightness or the surface reflection, and the reach. Again, I am using the same lunar targeting package that the crew is referencing on board right now. This helps keep them on time as well as prompt them for when they need to make a call down to the science team and report what they're saying. It also gives them reminders of when they need to swap positions at the windows. Additionally, I'm using the Artemis II Lunar Science Passport developed by Amber Turner and the Artemis II Lunar Science team. Now, this passport did not fly with the crew, but they used it extensively as a study guide here on Earth. So a lot of the descriptions and comparisons you hear today are developed directly by the science team. We are now 4 days, 20 hours, and 43 minutes.
Science integrity, that crater to the north, that is, it's like we've got one in the north that looks like just a textbook crater, and one on the South Pole as well. The one on the north, I think, is Pythagoras. And what I wanted to highlight about that is it is either a very distinct central uplift or just a very defined area of high albedo. If a majority of the crater, especially the floor of the crater, is, say, an albedo of 5, this center, and gosh, only a tenth of the diameter of Pythagoras is an albedo of 2, maybe 3, but it is very bright and it stands out. And then between that crater and the actual what is the horizon from here, there seems to be another crater right on the horizon, and right on the edge of that is another patch of that albedo. It seems to be between the two craters. It's hard to tell from this grazing angle, but there is another spot just further north beyond Pythagoras. Between the two, I can draw a picture of this one and show you where that very high albedo, again, another 2 albedo surrounded by 5 and most of the area bounding it.
Integrity science, thanks for that. We agree with the Pythagoras assessment. And as a follow-up to your previous report, the SIR had questions about topography comparisons between the North Pole and the South Pole of the Moon, if you're willing to provide words on that.
Topography comparisons, absolutely. And if you have any idea what, if you draw a line between Pythagoras and the western edge of the outer defined ring of Orion, it intersects a beautiful textbook crater on the south. I would love to know the name of that. The topography differences, now the South Pole has a little bit of a benefit that it has more of the terminator, and I can see a little more shadowing there, but there's a nice crater right at the South Pole, so that's the main thing defining the topography there. Seems to be quite 90 just to the west of that crater at the South Pole. I can see a very distinct change in the shadow directions, indicating, I don't know, a very high wall or a very deep canyon just to the west of that. And the north be that from sort of the edge of the mare that's dark, which is maybe 1 Pythagoras diameter south. If you draw a ring about that, maybe the top 7 degrees of the moon, and just draw a ring around that. The near side is an albedo of 5 and looks quite smooth from here. And then along the same edge of the mare, the edge of the mare that kind of Grimaldi's just outside of, is just outside of, and you start to see the dark differences between the darker 8s and the 5s and 6s, the 4s and 5s. If you follow that line up to the north, that line is also where the change into the North Pole. The line defining the light and dark on the edge of the mare that you can see from Earth. Draw that line, roughly the midpoint of all that, straight to the North Pole. And on the side facing the Earth, you see smoother topography and dotted by Pythagoras and its next door neighbor crater. And then on the far side, you see a lot more cratering and a lot more topography. And again, the far side has the benefit of a little terminator there, but I am seeing a variation in the topography. It seems to be more jagged and a more challenging place to find a place to land and to even traverse in the all around the South Pole. And at the North Pole, it seems to be would be more challenging to translate on the far side of the North Pole compared to the near side of the North Pole around Pythagoras.
Copy all, Victor. You really help paint a contextual picture of what you're looking at. We really appreciate the way that you're guiding us into the areas you're seeing by drawing comparisons between recognizable features. Thanks for that.
And Kelsey, another little science sit-rep moment, something I just heard from the window team is the more I look at the moon, the browner and browner it looks. I thought that was an interesting observation. The 2 observers have been on timeline, no hardware issues. They did start to talk a little bit about another feature that you'll hear more about on the recordings that they call the handprint. That was at the end of their Glushko and before they moved into their current target. They thought that was worth chatting a little bit more about. And they're preparing to switch after this.
Houston copies and concurs.
Hey, Houston and Science Integrity, another just observation from the human my eyes have shifted a little bit since I've been up here. I've been wearing my reading glasses to look at the PCD. Well, this is a very taxing event on the eyes, looking out the window and seeing the very bright moon, then coming back inside to the dark cabin and trying to work cameras and microphones and logistics and lunch and those kinds of things, and then looking at the PCD, which is dimly lit. It's just been an exercise. It is a difficult thing to manage it. I'm up and down on the glasses and then having to wait as my eyes adjust when I come back in. As soon as I look back into the cabin from looking out the window, I can feel my eyes adjusting, and I just have to work through it as they adjust.
Appreciate that report, Victor, and know that we are prepared to read you up targets from the ground if that would give you the ability to keep your eyes focused on the moon and not having to swap between that and the PCD. Just let us know.
Yeah, we appreciate that, science, and we will also do that for the window teams, and we'll back each other up that way as well. But we appreciate that. We may take you up on that. Thanks.
Continued detailed descriptions from the Artemis II crew aboard Orion. Again, this is a test flight, the first time we've flown humans aboard this spacecraft. So every detail, even that it's difficult to look outside the window and then back at the PCD, that portable computing device, every single detail is appreciated as we prepare for future missions. Glover also mentioned that he is now wearing his glasses now that he's in space and that his eyes have shifted a bit. This is something that happens when our astronauts go to space. There is a fluid shift from the lower half of your body up into your head, and that can cause changes in your eyes. It's something that we have seen over time for some crew members, especially now that we have been living and working on the International Space Station for over 25 years. Again, it's clear that these Artemis II astronauts have undergone extensive lunar science training, including classroom instruction, fieldwork, and high-fidelity simulations. Training expeditions even took place in analog environments like the Icelandic Highlands and the Kemasassen impact crater in Labrador, where crews practiced identifying and describing geologic features under varying conditions. Additionally, here at Johnson Space Center, Orion mock-ups were used to rehearse crew choreography, including three-dimensional space management with an inflatable moon globe to simulate the flyby. And while on Earth, the crew also used that small lunar passport that I mentioned with descriptions, photos, and prompts to help them study the features we hope they'll see. Now, this is a view from their lunar targeting package at this time, helping them determine what they're seeing on the moon, as well as on the left, keep up with what their next target will be. As you can see, we have got a long list and an exciting day ahead of us. It's now been 4 days, 20 hours, and 53 minutes since Orion launched atop the Space Launch System rocket from Kennedy Space Center in Florida with our 4 crew members aboard. NASA astronauts Reed Wiseman, Victor Glover, and Christina Cook, and Canadian Space Agency astronaut Jeremy Hansen. The Artemis II crew passed a major milestone today when they passed the Apollo 13 distance record at 12:57 p.m. Central, 1:57 p.m. Eastern. That Apollo 13 distance record on Earth.
And then the moon. Look at the moon. Something I've never seen in photographs before, but is very apparent. All the really bright new craters. Some of them are super tiny. Most of them are pretty small. There's a couple that really stand out, obviously. And what it really looks like is like a lampshade with tiny pinprick holes and the light shining through. They are so bright compared to the rest of the moon.
We copy, Christina. Thank you. Looks like you guys might be doing it, but remind you to swap positions at the window and take your SD cards with you. We're loving everything that you're calling down, so keep it up.
Again, Orion previously surpassed that the Apollo 13 greatest distance from Earth by humans. That was 248,655 statute miles from Earth, and Orion now 250,294 miles away from our home planet. The spacecraft is 9,033 miles away from the moon and growing ever closer. At its closest approach, it'll be about 4,070 miles away, and we will make sure we confirm what that distance ends up being. This is an approximation and an estimate ahead of that moment. We're anticipating them to make that closest approach at 6:02 p.m. Central, 7:02 Eastern, when they are in a loss of signal, transiting behind the moon. They will be the first humans in over 50 years on Earth. We will regain that contact about 40 minutes later as they reconnect to the Deep Space Network, emerging from behind the moon, and we will look forward to seeing an Earthrise. Again, the crew is currently in their position swap portion on their timeline. This allows crew members the opportunity and the experience of all roles necessary during today's flyby. Right now, those two crew members at the window have swap positions. Again, the crew at the windows swapping positions. Right now, that crew is Commander Reed Wiseman and Mission Specialist Jeremy Hansen, while Victor Glover and Christina Cook serve as their support flyby crew members. That's why you are hearing Victor and Christina during those science situation reports. Those voices will change in about 30 minutes when they take a turn, taking photos and making annotations while at the window.
Houston, integrity. I wanted to provide an observation or a little bit of descriptive nature on something that we saw on the first day we had good moon views. This was when we saw more of the near side, and the ground helped me out with identifying Mare Imbrium. Mare Imbrium, when you have the western limb also in view, looks completely different than the normal view we have of the near side. It is the most striking feature of the western limb view that we had. And the mountain chains that form its eastern side are very prominent, but they actually stand out more than I'm used to seeing even on the western side, and the whole thing just feels like a big bump. It actually looks like a large healing wound with a high albedo forming the mountain chain around the impact basin. And I just don't think I had enough chance to describe how striking it was on that western limb view as we were coming in a couple days ago.
Christina, science, absolutely love that, especially since that's a feature that all of us here on Earth can observe from home. So I'm sure tonight everyone's going to be going out and looking for evidence of that beautiful topography you just said. Thanks for those words.
The view on your screen coming from Orion, a camera mounted on the spacecraft's solar array wing. Toward the right of your screen, the near side is the hemisphere. That is identifiable by those dark splotches, which are ancient lava flows.
Science integrity. A question and a comment. Possible that we're seeing a Schrodinger basin from this vantage point in the Terminator at the South Pole. And the comment is Ohm. The rays coming out of Ohm are less distinct. We are not seeing the bright rays coming out of it, but the sort of 9 o'clock wedge that is formed by the change in albedo from the interior portion that is to the northeast to the surrounding lighter mare that's 270 degrees to the west. That 90 is very distinct and interior. You got some great descriptions from the two at the window about the colors in there, but in that darker part, in that wedge, you've got some really interesting color, even though the rays, the distinct difference in the albedo almost look like rays, but it's not the rays coming out. It's the just change in that albedo.
Integrity science, that is very intriguing, those color rays coming out of Ohm rather than sort of albedo. And as answer to your question, we do not think you can see Schrodinger. It's in darkness as of now. But thanks for that Ohm description, and it sounds like the pair at the window's got great descriptions that we're definitely going to dive into tonight.
Okay, if you could help me out. I still love to know what it is. I very likely have a lot of pictures of it right in the Terminator at the South Pole or close to the South Pole. It's intersecting the Terminator right now.
Yeah, Victor, we're thinking about, kind of if you're looking at the Terminator it's basically like 70% down from the North Pole.
That is where I'm looking.
Integrity Houston, that is an enabled caution for wastewater dump required. We have hit our limit. As expected, no crew action.
Copy, no crew action.
You are, and integrity, we're trying to figure out what you're looking at there. Is it like right on the terminator, or is it in portion next to the terminator?
We wait for a response from the crew. The terminator is that difference between day and night, or brightness and darkness, that you see on the moon. We see this from the International Space Station as well, looking down at Earth.
And science from integrity, excuse my space orientation adaptation. If you draw a line between Glushko of Oriental and then another line from Glushko through the southern tangent of Oriental, that line tangentially the crater that I'm talking about, and it is on the terminator. So yeah, I think I'm not looking at the South Pole. I was a little twisted.
That line description was really helpful. I have eyes on this right now, and they are actively discussing lunar geography. We will be back with you shortly.
You're hearing a couple of voices today in Mission Control Houston. One of those is Dr. Kelsey Young.
Integrity Science, we believe that's Zeeman Crater.
Oh, I floated away from the speaker. Say it again, please.
We believe that that is Zeeman.
Zeeman. Okay. And can you say the first letter? That's wrong. What's the first letter of that word?
M-A-N.
Copy. Thank you for that. Yes, we've got a great view of that. And when I went back to the window just now, the view has completely changed. Our trajectory is taking us to a new view, and I'm looking more into Babalov. I've got a nice great view into Babalov. I'm actually away from the window right now, so I'm going to go try to give you some bounding words on the view that we're seeing, but I've got to get back to a window in a minute.
Understood, Victor. You're defining new views of the moon in more ways than one.
Again, when you hear calls down to science or from science, that's Dr. Kelsey Young, the Artemis Science Flight Operations Lead here at a console in Mission Control. You also hear communications with the crew from Canadian Space Agency astronaut Jenny Gibbons. She is the Capcom for today. She is a backup Artemis II crew member. Those calls from pilot Victor Glover asking about a feature he was seeing, specifically a crater on the moon. Meanwhile, the team here in the science evaluation room was actively working together to determine which feature he was describing. The teams at the window have continued to move through their targets, including Ohm, Aristarchus Plateau, Reiner Gamma, and we are preparing for the cabin and window teams to swap. That's when we'll hear more from Reed Wiseman and Jeremy Hansen when they take on these support roles, while Christina Cook and Victor Glover are at the windows photographing and annotating. As we briefly mentioned, if you look towards the right side of the moon, essentially, this live view coming from a camera outside the Orion spacecraft, and if you look on the right side of the moon where you see those dark patches.
Wow, yeah, I wish I had some more time to just sit here and describe what I'm seeing, but the Terminator right now is just fantastic. It is the most rugged that I've seen it. From a lighting perspective, there are little islands. There are islands of terrain out there that are completely surrounded by darkness, which indicates some real variation in terrain. Up to the north, there is a very nice double crater. It looks like a snowman sitting there. In the 5-10 degrees below the pole in the Terminator, and then on the southern edge there's almost like a hole. Looks like a hole, and it's the diameter of Vavilov size, just blackness, and then a wall of bright, and then it goes back to the black beyond the Terminator. So there's it looks like there's just a gigantic hole right there. 1 Vavilov diameter east of the Terminator, and as you go south, the Terminator is not a nice smooth arc. It's just jagged. There's almost a 110-degree turn in the shadow as opposed to the nice smooth arc, again indicating some really interesting variations, and I'm sure we'll get some photos of that. And then one of the craters further to the south of Vavilov, maybe halfway down to the South Pole, is not only looks like just a deep hole, and then there's like 2 island rays pointing off to the west and north that indicate very high ridges and very deep canyons coming up out of that crater. So again, just some really interesting illusions going with the shadows there. Like I said, there look to be islands out beyond the Terminator, because some of the things, maybe even a Vavilov diameter into the Terminator are catching sunlight on the peaks up to the north and to the south. It's very, very interesting to see.
Integrity science, oh my gosh, that was an amazing picture you just painted. I glanced over at the SIR video and I literally saw fist pumps in the air. Those types of observations are things that humans are uniquely able to contribute, and you just really brought us along with you, so thanks for that.
That's awesome, Kelsey. Did you get a sit rep updating you on a slight change in logistics for PCD use?
Christina, this is Houston. We did not, but we will take it now.
We slightly changed the PCD plan for the window observers. The 2 window observers kept their PCD. So in other words, the one at window 2 went to window 3, and the one at window 3 went to window 2 when they swapped, rather than staying at the window. We'll plan on all observers keeping the same PCD for all observations.
Copy, Christina. That makes sense to us, and good plan. We are coming up here on a cabin and window team swap. Let me know when you're ready for a quick vehicle status.
As you heard, science.
Houston, go for the vehicle system update.
Hi, Reed. We don't have much for you. We just wanted to let you know that toilet right now is no-go for use as we stick with the predetermined limit for now. All crew members, please use CCUs. Otherwise, Orion is looking very good. And you have 15 minutes in this handover time where we expect Victor and Christina to switch to the windows, and you and Jeremy have been assisting. Let us know if you have any questions.
No questions at all, and they're in the swap right now. The first thing I'll tell you, I floated up to the docking hatch window, and just what I'm going to call the Mari around Oriental just looks so different out the docking hatch right now. It's quite a bit darker. It's the same darkness, if not a little darker than Grimaldi, but it's cool after just being in the 400 mil for the last half hour, looking up close. I got pictures of everything Ike was just describing on the Terminator. It really is a fascinating Terminator, and then Oriental just looks so dynamic right now. It's very three-dimensional out the docking hatch compared to what I was just looking at through the 400 mil.
We love it. We are getting a sneak preview from one of our SAW cameras at what you're looking at, and we see some of what you're describing. We cannot wait to see your photos. Thanks.
Yeah, Jenny, I wish you had some longer lenses on the solar array so you could see the whole moon, but man, it is, or the up-close moon, not the whole moon, but it is just fascinating here. It's so cool.
All right, MPO and Inco, take notes. We want a zoom lens on those saws next time. Thanks, Reed.
Affirmative.
As the crew gets ready to switch positions from the window crew going back to the support crew, and the support crew flying up to the windows. This view inside the room, Capcom Jenny Gibbons speaking with the crew, Canadian Space Agency astronaut. The crew has continued to provide excellent descriptions of what they are seeing on the lunar. In this picture, or in this live view actually, from Orion and a camera mounted on its solar array wing, if you look at the on the screen, those ancient lava flows early in the moon's history when it was, if you look towards the left, there's that dark large crater that appeared above left those lava flows. It's about 600 miles wide, and it is first time able to see this with their view as well between us on the moon. Victor explaining that jagged looking Terminator peaks that they're seeing and the craters that they're seeing as they prepare to cross over the also heard officer the Dr. Young lead sharing with Victor Glover that his responses are human eyes can discern or prove. So we've previously discussed how having humans observing the moon on this mission is being combined with lunar optimize what we know about the moon. So part of that data comes from the Lunar Reconnaissance Orbiter, or LR. This provides the robotic that makes Artemis 2 lunar science possible. LRO years, which makes a long operated or history. And it's also the dedicated specifically to lunar observation to data like the detailed surface images from LRO. So while LRO provides those detailed high-resolution maps of the moon's surface, the Artemis II crew adds human observations that focus on regional context and relationships between features, giving scientists a larger geologic picture. Now, this combination of robotic and human observations strengthens lunar science. LRO delivers precise and repeatable measurements over long periods of time, while the Artemis II crew contributes real-time visual descriptions and context that robotic instruments alone cannot provide. The best description I've heard while preparing for this mission is to compare the difference in looking at the moon with your own eyes on Earth and trying to take a picture with a camera. The camera truly never does it justice, and it's much easier to describe and perceive what you're seeing with your own eyes than to take a photo. These Artemis II astronauts can rapidly scan wide areas and adjust their focus in real time, as well as describe relationships between features. The crew will also observe the same regions multiple times under changing lighting conditions during the flyby and provide perspectives that would take robotic missions years to accumulate. During the Artemis II mission, LRO is also attempting to observe some of the same lunar features that the astronauts are studying. Collecting this data simultaneously highlights how different instruments and human eyes provide complementary information about the moon. This LRO data plays a direct role in preparing for future Artemis missions. Its measurements of topography, surface temperature, composition, radiation, and lighting conditions are used to assess hazards, identify safe landing sites, and locate potential resources such as water ice near the lunar South Pole. This mission, Artemis II, represents the point where years of robotic preparation are paired with human exploration for the first time in the Artemis era. So together, LRO, the Lunar Reconnaissance Orbiter, and Artemis II are demonstrating how NASA moves from mapping the moon robotically to exploring it with humans. We are laying the groundwork for future Artemis missions and sustained lunar operations. A check-in with Orion. We are now 4 days, 21 hours, and 22 minutes into the flight of Artemis II, our crew aboard the Orion spacecraft. We are now 8,153 miles away from the moon, 250,742 miles away from Earth. The spacecraft is traveling at 1,030 miles per hour.
All right, Houston, the professional science update giver is now in seat 2. That is where Victor is, and Christina is nestling into seat 1 with the long lens, and we're just getting ourselves oriented here. It's a cool view in the cabin. It's actually a cool view to be off the camera now and looking at my crewmates getting up to their observation post and looking in. It's super fun.
Copy, I'll read. We like it.